Welcome to the Knowledge Lab. Fuel your mind with science. Have you ever wondered why we all see the same reality? I mean, if quantum physics says that particles can be in two places at once, that reality is full of uncertainty and possibility. Then why don't we ever see that? Why don't you ever wake up to find your coffee cup half here and half floating in midair? Why does everyone see the same cup in the same place, doing the same thing? This is one of the deepest mysteries in physics. And a mind-blowing idea called quantum Darwinism might just explain it all. Let's go into the quantum world for a second. In this world, particles don't behave like tiny marbles. They exist in what's called a superposition, a cloud of possibilities. A single electron, it could be spinning this way and that way at the same time. It could be here and there, all at once. Only when we observe it, when we measure it, do we find it in one specific state. It's as if the particle was undecided until we looked. But here's the catch. We don't see this fuzzy, probabilistic world in real life. We see solid things. Cats don't flicker between walls. Tables don't blur into clouds of maybe. And here's the big question. If quantum physics rules everything at the fundamental level, why do we experience such a stable, shared classical world? This mystery, how the strange rules of the quantum world give rise to the predictable world we see, is known as the quantum classical divide. It's puzzled scientists for decades. Because, logically, if everything is quantum, then why isn't everything weird? Why don't we all experience our own version of reality, like different dreams of the same world? This is where things get really interesting. Because one physicist, Wojciech Zurek, proposed a revolutionary idea. It's called quantum Darwinism. Think of it like this. In biology, we know how Darwin's theory works. Organisms evolve. The strongest survive. The weak die off. It's called natural selection. Now imagine applying that same idea to quantum particles. That's what quantum Darwinism does. It says that in the quantum world, different possible states of a system compete to become part of our reality. But not all of them make it. Only the fittest states, the ones that are stable, redundant, and easy to copy, get to survive and be seen. And where does this selection happen? In the environment. Let me explain. Every quantum system is surrounded by an environment. Light, air, atoms, even photons bouncing around. And guess what? That environment is constantly interacting with the system, like a swarm of tiny observers. But it doesn't collapse the system into chaos. Instead, the environment records information about certain parts of the system. But not just any information. It selectively amplifies the most stable, robust, and shareable quantum states. These stable bits of information get copied again and again, like rumors spreading through a town. Soon, everyone, meaning any observer, can access this information because it's been broadcast by the environment itself. That's the trick. What we call reality is simply the information that has survived this quantum natural selection process. Let's make this visual. Imagine a quantum coin that could be both heads and tails at the same time. Now place it in a room filled with mirrors, fog, and cameras. This room is your environment. As the coin exists, those mirrors and cameras start recording reflections of it, snapping photos, bouncing light, leaving imprints. But only the clearest image, let's say heads, manages to get reflected everywhere. The fuzzy, weird images, they disappear into noise. Now, if two people walk into the room and look around, they both see the same thing. Heads. Not because that's the only thing that could have happened, but because that's the version the environment selected and copied. That's quantum Darwinism in action. Now here's where it gets really exciting. For years, quantum Darwinism was just a beautiful theory. But recently, physicist Akram Tuil and his team at Los Alamos National Laboratory took a giant leap. They mathematically proved how the environment's redundant encoding of information leads to a shared, objective reality. Their equations showed that when different observers look at the same system, they're all accessing the same slice of environmental data. That's why we don't each see our own private universe. We all see the same coffee cup, the same tree, the same sky. Tuil puts it simply. When you go outside, you see things as localized. You don't see weird quantum features. This theory explains why. And it might be the missing link between the quantum world and the classical one. So what does this all mean? It means that reality isn't what's inside the particle. Reality is what gets copied and shared by the environment. It means the environment is not just a silent background. It's an active editor, choosing what parts of the quantum world get published. And it means that objectivity, what we all agree is real, is not absolute. It's a consensus, a shared version of the truth, created by the universe itself through a cosmic survival of the fittest process. Quantum Darwinism might also be a bridge between the weirdness of quantum mechanics and the logic of classical physics. It suggests they're not separate realities, but different layers of the same unfolding process. It might even help us unlock new theories of quantum gravity or explain mysteries in cosmology, like how the early universe formed and became observable. This is more than physics. This is about how reality evolves. So next time you look around at your phone, your coffee, your reflection in the mirror, remember this. What you see isn't the whole truth. It's what survived. It's the version of reality that the environment selected, copied, and agreed to share. In a way, the world we know is the result of quantum evolution. Just like life, reality itself had to fight to be seen. And what we call real might just be the ultimate survivor.